morning, gentlemen. Good morning. We're now moving on to area. So we did perimeter last time, not last lesson, sometime not last term. So what was perimeter again? Who can remember? Yes.
Perimeter is the length of all sides over that.
Yes. Outer. So the length of the outer boundary of a shape. Yes.
Perimeter is the sum of the outer boundary of the shape.
Yes. And what were the units we used to measure perimeter? Yes.
We can use meters, centimeters, millimeters.
Perfect. So meters, centimeters, millimeters. So whatever units our lengths were in, the perimeter of a shape had the same units. We agree?
Yes.
Can we put our screens down, please, so we don't get distracted? Great, thank you. So what was a real life example? Give me one example where you would need to find the perimeter of a shape. In real life, we're using maths. Yeah.
When you're fencing around the house.
Yeah, fencing around the house. Yes, or fencing a paddock. You need to see how long is the boundary, so how much fence you need. Does that make sense? Okay, now we're moving on to area. So what's area? How do you describe area? Simple things like area, perimeter, length, we find hard to describe. Who can describe that for me, please?
Area is like the surface inside the shape.
Exactly. You've actually said the right thing. Area is the surface enclosed by a shape, inside the shape. Perimeter was just the outer boundary. Area is the surface enclosed by a shape. So for example, if I draw a shape, any shape, the length of the blue line is actually the perimeter. Yes, that's the boundary. But the surface inside a 2D shape is the area enclosed by it. Does that make sense? Now, can someone give me a real life example of where we would need to find the area? Someone actually said that example when we were talking about perimeter, and I said, no, I would not use perimeter then. So what would be a real life example of using area?
We need to find the area of a classroom.
Why would I need to find the area of classroom? Why? What use would that be to me?
To put the carpet in.
To put the carpet in. So if we were to put the carpet, am I just carpeting the edges? No. So perimeter won't work. Aren't I covering the whole surface enclosed by the classroom? Isn't the floor a 2D surface, a rectangle? And I'm covering the whole surface. When you're covering the whole surface, it's an area problem. So you need to figure out what is the area, and that'll be the area of carpet needed. Where else would you use area in your real life? Yes?
In a maths exam where you need to find the answer.
Your maths exam is not real life. Like a daily life. Like that's your educational setting only. Like out of your maths classroom, your maths exam.
When you need to figure out like how big like your house area is, so you can put your house in your pool or whatever.
Exactly. So, for example, I recently bought a house. When I was buying houses, I was looking at the cost of the house and how much the block was. What was the land size? Right? Because you need to know how big your land size is, and then if you want to put a pool in, do you have enough area in the backyard to put a pool in? Yep, that's a good example. Where else would you use it? Yes?
Like if you're getting new furniture, you have to see if it fits.
That would be area and some length as well, the length and the width as well. So where else would you need to know the surface? So carpeting was one. What was something else?
Tiling.
Tiling, yes.
I guess if you were to make like a fake grass oval.
Yes, artificial turf. You would need to know the area. Okay, so there are a lot of examples, but you need to remember the difference. Perimeter is the length of the outer boundary, so it's only the length. The units were meters, centimeters, millimeters, kilometers, depending on what your shape or how big your shape was. Area is the surface enclosed. So what is area? Now we know the surface enclosed by a 2D shape. Where do we use it in daily life? Tiling, carpeting, so wherever we need the area. Units of area then. What are the units of area? How do we measure area? What are the units of area?
Squared.
Exactly, it's squared units. So for example, if I have a square, so let's say this is a square of side 1 centimeter by 1 centimeter. The area enclosed by this square is 1 squared centimeter. Okay, because it's 1 centimeter times. So the area of a square is length times length, 1 times 1. So units of area are always squared length. So squared centimeters or square meters or square kilometers. because you're multiplying one side by the other to get the area. Okay, so centimeters by centimeters would be squared centimeters. But we write centimeter and then the squared sign. Right? So perimeter, the unit will be the unit of length. Area would be squared the unit of length. So centimeter squared. So squared centimeters, squared meters, squared kilometers. Is that clear? Okay. How do we calculate area then? Yes.
Length times width.
Yep. Or what if it doesn't have a length times width? So if I've told you that the area of, let's assume my drawing is not the best because I'm not an art teacher. So let's assume all these squares are actually equal in size and the side length is 1 centimeter by 1 centimeter. Okay? I'm finding the area of this shape. What shape is it in blue? Rectangle. I know that area of one square inside is 1 squared centimeter. How many of these squares has this enclosed? 6. So what will be the area of this rectangle? 6 squared centimeters. Okay, so if we know 1 squared is 1 squared centimeters, how many of those squares have been covered? 6. So the area of this shape is 6. Yes, there are some other formulas which we will learn about today, that for certain shapes, rectangle, square, parallelogram, trapeziums, we have formulas. We have already figured out the formulas. But what about these shapes? You have a question?
Would we, for like when you're saying like squared centimeters, could you also say centimeter squared?
You can say whatever you want, but the correct way of saying it is squared centimeters. Okay? Now, irregular shapes. Now, this is not a rectangle or a square or a circle. It's just a funny shape that I drew, right? How do we find the area of that? Now, can you see that I wrote calculate here? And I wrote estimate here. Was that because I just wanted to use a fancy word? No. Is this the exact area of this rectangle?
Yes.
Pretty much, assuming all squares are equal. Can we find the exact area of this shape? No. Can I find an approximation?
Yes.
Close to? Yes. So what we do is, we know that each square is, again, we assume it to be all equal, 1 centimeter in length. Any square that's fully covered is counted as 1. So is this fully covered?
Yes.
Fully covered?
Yeah.
1, 2, fully covered, pretty much. 3, right? So full squares, we count them as 1. Anything that's more than a half covered, we also count them as 1. Is this covered more than half? So I'll count it. Is this more than half?
Yes.
More than half?
Yes.
More than half?
Yes.
More than half?
Yes.
More than half?
No.
More than half?
No.
More than half?
No.
So I won't count them. So anything that's covered more than half, you count it as 1. Anything that's covered less than half, you don't count it. So we've counted a little bit more here, but we've, then not counted those were half. Again, answers will not be exact. They'll be an estimation. But this is the rule that we follow. Anything that's fully covered or more than half covered, we count them as 1. Anything that's covered less than half, we don't count it. So how many squares will we count? 1, 2, 3, 4, 5, 6, 7, 8. So what's the area?
8 squared centimeters.
8 squared centimeters. Is that the exact area? No. So I'll put the approximation sign. Does that make sense? So again, answers for the irregular shapes will be an estimate. The answers for regular shapes will be exact answers. So any square that's fully covered is counted as 1. Any square that's covered more than half is also counted as 1. Any square that's covered less than half is not counted at all. So we kind of balance, we're adding a little bit more, but we're not adding some. Again, it's an estimate. Yes?
You know how you word like the fully closed squares? We have to write all that working out.
Depends on the number of marks. But as long as you show this or some kind of working out, I know that you've counted the squares, which ones you've counted, which ones you've not counted. As long as there's some indication of your thinking behind the answer, you'll get the working out marks. Yeah, but you can write fully covered. How many were fully covered?
2, 4, 3. No, 3. Sorry.
3?
3.
1, 2, 3. Then more than half covered.
5.
So, 5. So that's all you count. So total, 8. So area is 8. Make sense? But that's an estimate. So that is area. We will now move on to finding the areas of rectangles, but without the squares, with just formulas. Do you have any questions on this one? Okay, get on with your work.